Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Largest combination with bitwise and greater than 0. Leetcode 2275. In this problem we are given an array of positive integer candidates and we have to evaluate the bitwise AND of every combination of numbers of candidates. Each number and candidates may only be used once in each combination and we have to return the size of the largest combination of candidates with a bitwise AND greater than 0. The bitwise AND of an array nums is the bitwise AND of all integers in the numbers. For example, for given input nums equal to 1, 5, 3, the bitwise AND is equal to 1 and 5 and 3, which is equal to 1. Because bitwise AND takes each bit of the number and performs the AND operation. If all bits are 1, the result is 1, otherwise it is 0. For example, binary representation of 1 is 001, binary representation of 5 is 101, and binary representation of 3 is 011. So now if we perform the bitwise AND operation between these numbers, the output will be 001 because there is only last bit where all the inputs are 1. Also, for nums having only one element, for example 7, the bitwise AND is the number itself, like 7. Then in example 1, for the given candidates array, the combination 16, 17, 62 and 24 has a bitwise AND greater than 0 and the size of this combination is 4. And then Leetcode says that this is the largest possible size for any combination having bitwise AND greater than 0, and there may be many such combinations resulting in this largest size. And as this is the largest size, we will return 4 as our answer. Now in terms of solution, one of the naive approach can be that we generate all possible subsets of the given array, and then for each subset we calculate the bitwise AND of all its elements, and among them track the size of the largest subset where the bitwise AND is greater than 0. However, this approach is super inefficient because generating all subsets require a time complexity of 2 to the power of n, where n is the number of elements in the input array. And on top of that, we have to calculate the bitwise AND for each subset, which will take O of n time. Therefore, the overall time complexity of this approach will be O of n into 2 to the power of n, which becomes impractical for large inputs. Also, here we don't need the actual combination, just the length of the combination. So let's see how we can do better. When performing the bitwise AND operation, each bit of the number is ANDed together. If all bits are 1, the result is 1, otherwise it is 0. For example, we already saw bitwise AND of 1 and 3 and 5 was equal to 1, which was more than 0. Therefore, we can include all the 3 numbers in the combination. However, instead of 3, we had number 2, and then we have to do bitwise AND between 1 and 2 and 5. Then bitwise AND of all of these 3 numbers will result in 0. So we cannot include all the 3 numbers in the combination. Instead, we can pick the largest subset where the bitwise AND is greater than 0, which in this case is of size 2 with numbers 1 and 5. So to form a combination where the bitwise AND is non-zero, we need to have at least one bit set in the resulting number. This bit can be in any position in the number. It can be at 0th position, it can be at the first position, second position, or any position, right? And this helps us find the non-zero combination. But what about the longest one? When we perform the bitwise AND operation, we perform it at different positions in the number. Typically in programming languages, integers are 32 bits. So this is 0th position, this is first position, this is second position, and so on all the way up till 31st position. And we perform the bitwise AND operation bit by bit. Now suppose in the input numbers, we have two numbers which have 0th bit set and rest of the numbers have 0th bit unset. Then if we do the bitwise AND between these two numbers, then the last bit in the result will be set. Similarly, now we go to the next position and count how many bits are set in the input numbers. Let's say we got 3. Then if we pick these 3 numbers in the combination and perform the AND operation between them, then the result will have a set bit on the first position resulting in non-zero value, and the combination size will be equal to 3. Now between the combination size of 2 which was created at the 0th bit and combination size of 3 which is created at the first position, which combination should we pick? And the answer is at the first position because we want the largest combination. So we have to be systematic and go through all bit positions, typically 32 bits in most programming languages, and count number of ones or set bits at each position for all the numbers in the array, and then the maximum count at any bit position gives us length of the largest possible combination. So we greedily choose the count of the position where we have the most set bits. Now coming back to our example, this is how the binary representation of numbers look. We can see that there are only two integers having the 0th bit set, while at first bit position there are 3 numbers with the set bit. For second position there are 4 numbers with the set bit. So we can form a combination of size 4. Then at third and fourth position we again have 4 numbers with set bits. And at the bit position 5 and 6 there are only one each number with set bit. So this is a least favorable combination size. So throughout the counting, since the highest number of set bits were 4, we will pick 4 as our answer. Now the question is, how can we find number of set bits in the integer at different positions? And for that you can refer number of 1 bits problem, where actually I have already covered the concepts, but here I will cover it briefly. For example, let's take the number 5. The binary representation of 5 will be 101. Now first approach I will be covering is using modulo operator and division. So if we do 5 modulo 2, we will get 1. That means it is odd and we get the 0th bit position set. Then we divide 5 by 2. So now we get 2 and binary representation of 2 is 1 0. Then again we do 2 modulo 2 and this time we will get 0 because 2 divided by 2 does not leave any remainder. So first bit position in 5 is not set, and then we again divide 2 by 2 and now we get 1 and binary representation of 1 is 1. So 1 modulo 2 will again give us 1. So second bit in 5 is set. Now we again divide the number by 2 and this time we will get 0. So for any number we will continue doing this process until the number becomes 0. We count the bit positions from left to right. Another approach can be that we perform bitwise AND operation of the number with 1. For example, let's again take 5. If we do 5 and 1, then we will get 1 as output. So that means 0th position in 5 is set. Then we can apply right shift operator or divide 5 by 2 like in previous approach. So we will get 1 0. Then if we do AND operation with 1, we will get 0 this time because 0 and 1 is 0. So this time that means this bit position was not set. Let's write it down. So this was 1, then we got 0. Then we again do the right shift. So we will get 1 and again 1 and 1 is 1. And now when we right shift 1, we will get 0. So we are done with this number as well. So that's how we will get set bits on 0th and second position in number 5. So then our idea is simple. We can create an integer array of size 32. Let's call it bits to keep count of ones or set bits in an integer at each bit position. And then for each number in the array, we will update the count of ones whenever we see a set bit at a particular position. And finally, we will traverse through the counts array and the maximum value among counts will be our answer, representing the largest combination size. Now let's jump into the code part. First, let's create the bits array of size 32 to store the counts of set bits at each bit position. Now we can go through each number in the given candidates array and we will check the set bits from left to right. For that, let's initialize the index variable to track the bit position starting from the least significant bit. Now, while the current number is greater than 0, we will check the least significant bit using the bitwise AND operation of the number with 1. If this bit is set, we will increment the corresponding index in our bits array by 1. Otherwise, it stays the same. And after checking this least significant bit, we right shift the number by 1 position and move to the next bit position by incrementing the index or bit position. And after processing all the numbers, we iterate through the bits array again to find the maximum count of set bits at any position, as this maximum count represents the largest combination size for which bitwise AND is greater than 0. Now let's return this answer. Now let's submit this code. Cool. In terms of time complexity, it will be O of n, where n is the number of elements in the array, because we are going through these elements one by one, and then at maximum, we are shifting through 32 bits in the number till the number becomes 0. And because of this, the time complexity will be O of 32 into n, which is O of n. And in terms of space complexity, it will be O of 1, because we are using this 32-bit array, which is a constant space. And now the question is, can we do better? And the answer is yes and no. Asymptotically, the answer is no, because we already have the best algorithm. You can see that it beats 100% of the Java runtimes. But we can still save this 32-bit space used by this bits array. Let's see how. First, let's get rid of this bits array. Instead of iterating through the numbers first and then through the bits position, how about we iterate through the bits position first and then go through each number. So let's loop through bit positions from 0 to 31. Let's also define the counter, which will track number of bits set for this position. We can go through the bits position first, and then for that bit position, we will go through each number and increment the count by 1 whenever we see a bit set on that particular position. And now we will go through the nums array like earlier and check if the bit position is set in the number. And how can we do that? We will just do the AND operation between the number and 1 left shift I. So for 0th position, 1 left shift 0 will be 1. For first position, 1 left shift 1 will be 1 0. For position 2, 1 left shift 2 will be 1 0 0, and so on. And if the AND operation between these two numbers results in 1 bit set, how can we check that? If the AND operation results in some non-zero value, like for second bit position, that value will be 4. For first bit position, that value will be 2. So if we get some non-zero value, that means that bit position is set, and we will increment the counter at that bit position by 1. And maximum among these counts will be our answer. Let's move the answer variable above and set it to current count if current count is more than answer. And finally, we will return our answer. Now let's submit this code. Cool. This time runtime dips a bit, but still the time complexity is 32 into n, where n is the number of elements. And the reason is, first we are going through this 32 bits, and then for each bit position we are going through each element in the candidates array. And in terms of space complexity, it is still constant because we are just using one or two variables here and there. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.